Number 3. Use the quadratic equation y equals x squared minus 6x plus 11 to answer each of the following questions. Find the vertex of y equals x squared minus 6x plus 11 using the formula x equals the opposite of b over 2a. This will be given to you on the test. Write your vertexes in order pair. And by the way, when you look down here in the directions, it says turning point. Well, turning point and vertex are synonymous. So the thing is, on this problem, a is 1, b is negative 6, c is 11, and we're going to fill in our formula. So it's going to be x equals the opposite of b divided by 2 times a. Well, double negative is positive, so it's 6 divided by 2, and x therefore is 3. And actually what that is it's the axis of symmetry. And once we know the axis of symmetry, we're going to take that value of 3 and we're going to put it back into the equation that we're given, and we want to figure out what the y value is. So that x equals 3 is the x value of the vertex or the turning point. So we pull out our calculator and we type in 3 squared minus 6 times 3. We're putting 3 in for x wherever we see it in the equation. Wherever we see x in the equation, you get 2. So our vertex is 3, 2. The value of a in this problem is 1. 1 is a positive value, and therefore that means that this is going to be a minimum. And if you're not sure, and it doesn't always work, but if you're not sure, go into the y equals and type in x squared minus 6x plus 11 and see if you can tell from the picture. Do we have a maximum or a minimum value? And what we just found is this point right here, the vertex, and as we can see, it's a low point on the graph, and therefore it's a minimum. Lastly, we want to identify the y-intercept, written as an ordered pair, and the y-intercept always has a x value of 0. And in our problem here, by the way, it's 0c. So c in our problem we determined right at the beginning is 11. Now it says on part B, now use the method of complete square to put y equals x squared minus 6x plus 11 into vertex form, and then use this to verify your work from part A. Well, we've got, I'm going to just write down the problem again, y equals x squared minus 6x plus 11. And first of all, what we're going to do is we're going to move the 11 over to the other side. We're putting all the x's on one side and the constant on the other. So we get negative 11 plus y equals x squared minus 6x. And then what's going to happen is we're going to get plus something. We do not have any number in front of the x squared term, which is good, because now we don't have to worry about that. And to figure out what's going to go in that box, we're going to take negative 6 divided by 2. It's always divided by 2 is negative 3 and squared. We get 9 here. Negative 3 times negative 3 is a positive 9. And we get 9 over here. Now it's pretty much downhill. On the left side here, 9 minus 11 is negative 2 plus y. And over here on the right side, I'm kind of combining steps, but we're going to factor. And remember, in these parentheses, they need to be the exact same values. X and x. 9 is 3 and 3. And since there's a minus in front of the 6x, there's a minus in there. Well, we still have negative 2 plus y. We can condense it down, and we have x minus 3 squared here. And lastly, we can add 2 to both sides. And when we add the 2 to both sides, I'm going to write it back in over here in the blank. You can't fit it in here. But we end up with y equals x minus 3 squared plus 2. And when we identify our turning point, again also known as the vertex, what we're going to do is we're going to change the sign so negative 3 becomes positive 3. We're going to keep the sign so positive 2 stays positive 2. And if we look back at part A, what we see for our vertex is we see 3, 2. And lastly on this particular question, it says, finally, looking at your vertex form, the quadratic, state the transformations that occurred. Do not abbreviate. Well, we went right 3. And we went up 2. Again, you might still have that picture in your calculator. You can look over here and see right 3 and up 2. Problem number 4, same idea. Use the quadratic equation y equals negative 3x squared plus 6x minus 7 to answer each of the following questions. So, like last time, we started with the fact that a is negative 3, b is 6, and c equals negative 7. And we're going to figure out, actually, the axis of symmetry first, which is that formula. Using the formula, x equals the opposite of b over 2a. So x equals the opposite of 6 divided by 2 times a. Well, that gives us negative 6 over negative 6. And negative 6 divided by negative 6 is positive 1. So our axis of symmetry is x equals 1. And once we know that, that's going to be the x value of our turning point. We're going to pull out our calculator, and we're going to type in negative 3 times 1 squared plus 6 times 1 minus 7. Depending on who your algebra 2 teacher was, you might have used the store button. It's one I particularly like. But we come up with the value of negative 4. Again, I don't know if it'll help or not, and actually I'm going to write it down before I type it into the calculator. But what we have is a equals negative 3, and when a equals a negative value, it means that that's going to be the maximum. Sometimes you can see it on your calculator, sometimes you can't see it on your calculator, but we can type it in to check. Negative 3x squared plus 6x minus 7. And we can see enough to tell this point here, which we just found, 1, negative 4, is a high point in the graph. Well, lastly, we need the y-intercept, and the y-intercept is going to be 0 something. It's actually 0c, and our c value here is negative 7. And then as we continue on down the page here, we want to put this into, using complete the square, put it into vertex form. And this one's a little bit trickier. I'm going to write the problem down again. Y equals negative 3x squared plus 6x minus 7. I'm starting with moving the 7 over to the other side. Add 7 to both sides. You get 7 plus y. There's nothing wrong with you writing y plus 7 equals negative 3x squared plus 6x. We need to factor out the negative 3. We can't complete the square when there's a number in front of the x squared term. So this is 7 plus y equals negative 3. And when we factor it out, be really careful. This becomes x squared, and that's not where the trouble is. It's 6 divided by negative 3, which is negative 2x. And now that we have this format, we can complete the square. But when we add our value over here to the other side, we can't overlook that this was negative 3 times x squared. We did negative 3 times x squared. Negative 3 times negative 2x. So what goes in this black box also needs to be multiplied by negative 3. And when we figure out what goes in that black box, we're taking negative 2 divided by 2 is negative 1, and square it, which is negative 1 times negative 1, positive 1. And it's going to be positive 1 over here. And remember, we already did part A, so we know what we're looking for. Once we get this in vertex form, will our vertices match? Because they should. Negative 3 times 1 is negative 3 plus 7. And over here, when we factor, what goes in the parentheses needs to be the same value. It's going to be 1 times 1, and the sign in front of the 2 is a negative, so these are both going to be negatives. Negative 3 plus 7 is 4 plus y. And then we get x minus 1 squared. And we'll subtract 4 from both sides. And I'm going to write this back in the vertex form here, so I can't fit it in. But we get y equals negative 3 times x minus 1 squared minus 4. I'm going to fix my negative in here. I'm going to switch colors there. You can't see it very well, but it's negative 3. And our turning point, well, change the sign. So negative 1 becomes positive 1. Keep the sign. Negative 4. And as I flip screens here, you can just look on your paper. Does that match what we had before? And the answer is yes. 1 negative 4 for a turning point there. 1 negative 4 for a turning point here. Then lastly, we need to identify all the transformations. And I don't always do this, but the negative out in front of the equation means that we're going to reflect over the x-axis. The 3, so notice that I separated them, because it looks like negative 3. That causes 2 things to happen, 2 transformations to happen. 3 is the vertical stretch. And then to change the sign, keep the sign. Well, minus 1 means that we're going to go right 1. And minus 4 means that we're going to go down 4.